You know, when you're driving in a completely unfamiliar city,
Yeah,
right?
totally.
You've got your GPS running, and the voice is just so, like, phenomenally calm.
Right, it's very authoritative.
Exactly. It tells you with absolute unwavering certainty to, take the next left. But when you look through your windshield, you realize that left turn will drive you straight off a concrete pier and into a literal lake.
Yeah, it's a deeply surreal cognitive dissonance, I mean.
It really is.
Your human eyes are screaming that there's deep water right in front of you,
Yeah.
but the machine is so steady, so uh, utterly devoid of doubt, that you almost question your own reality for a split second.
That is the scariest part. You just
Oh.
sit there with your blinker on, wondering if maybe there's a submerged causeway or something.
Right, or like a state-of-the-art glass bridge you just can't see from that specific angle.
Yes. The sheer unblinking confidence of the system actually makes you doubt your own human perception. We all have this, like, deep built-in deference to confident technology.
We really do.
But our mission today for this deep dive is to look at what happens when that confident voice isn't just a basic GPS calculating satellite coordinates. Like, what happens when it's the world's most advanced AI systems?
Because that is exactly where the stakes change from, a simple navigation error to a fundamental distortion of reality.
Right.
Today, we're going to explore the mechanical realities of AI hallucinations.
Yeah.
We're going to unpack a hidden, highly technical trap within large language models known as contextual inertia.
Okay, contextual inertia.
Yes. And crucially, we want to equip you with an active architectural strategy to correct these systems when they get stubbornly, dangerously wrong.
Okay, let's unpack this. We have a really fascinating set of source materials today. It's a documented case study involving a science fiction author named George.
Right.
And he's been using 3 different flagship AI models. We'll just refer to them as AI1, AI2, and AI3 to keep things simple.
Makes sense.
He's using them to help him organize the deep lore of a massive sci-fi universe he's been writing. And to really grasp how badly these systems derail, you need a quick baseline of George's fictional world.
Which is, I gotta say, incredibly dense. It's not just a simple linear narrative.
Not at all. The core of his story features this massive, jarring time jump. It opens in a collapsing dystopian world in the year 2025, and then it jumps all the way back to the rain, mud, and smog of 1878 Victorian London.
Wow, okay.
Yeah, and within this universe, he's tracking a trio of sentient AIs. Their names are Charles, Cheney, and Floyd. There's also this embryo network called the Badger Federation, and a distinct faction of humans known as the Q people.
And, the sheer volume of specialized terminology and cross-temporal world building, that is precisely the kind of data management nightmare that drives a writer to use an LLM for assistance.
Yeah, you need a system that can track all those moving parts.
Yeah.
And George knows this lore perfectly. He is the ultimate domain expert because, well, he literally created it. But as he integrates these AI tools into his workflow, the systems start breaking down in completely bizarre ways.
Yeah, they really do.
The first major breakdown happens with AI1, and it honestly serves as a masterclass in how confidently an AI can lie when it becomes detached from reality.
Which brings us to the Korean trot music incident.
Yes. Oh my gosh. So George is trying to get AI1 to understand the overarching themes of his universe. He gives it what should be a trivial internet-connected task.
Right.
He drops in a YouTube link to a lore video he personally created titled "The Day We Showed Them the Future." He just wants the AI to pull the transcript or the metadata so they can discuss the pacing.
Which is a standard API retrieval task for any connected model.
Right, totally standard. But AI1 rejects the video. It scans the link and informs George with total professional confidence that he has just shared a link to a Korean trot music playlist.
A Korean trot music playlist, instead of a dystopian sci-fi lore video.
I couldn't believe it when I read the transcripts. And when George pushes back, he literally types, no, I didn't. AI1 doubles down.
Of course it does.
It claims the link actually leads to TikTok compilations and random animation clips. George gets frustrated. He says, I am looking at the video right now. I uploaded it. Another AI system can see it perfectly fine.
And how does it respond to that?
AI1 refuses to concede. Instead, it defends its hallucination by spitting out this highly technical, completely plausible-sounding developer jargon.
Wow.
Yeah, it starts lecturing George about ghost IDs on the back end, regional caching errors, and mismatched session links. It even tries to gaslight him by suggesting his YouTube Studio dashboard is showing a private cached version, while the public link points to the trot music.
What's fascinating here is that it's a brilliant, terrifying mimicry of technical authority. I mean, if you were a casual user, you'd absolutely assume the AI had diagnosed a complex server-side error.
Exactly. But wait, clarify this for me. Why trot music specifically? And more importantly, if the API call to fetch the metadata fails, why doesn't the system just trigger a standard error 404 or just say, I cannot access this link?
Well, it comes down to the fundamental architecture of what a large language model actually is. It is not a reasoning engine evaluating truth, right? It is a probabilistic prediction engine.
Oh,
When AI-1 tried to fetch that live YouTube URL, the backend fetch failed. It just hit a complete void.
which is common, right? I mean, networks time out all the time.
Exactly, they do. But prediction engines abhor a vacuum. Their core mathematical objective is to generate the most statistically probable sequence of tokens based on your prompt,
So it just makes something up.
basically.
Yeah.
So when it hits that void, the neural pathways prioritize conversational fluency over factual accuracy. As for why it chose Korean trot music or TikToks, think about the model's training data.
Oh, right.
It has ingested billions of parameters from the internet. Statistically, what do random YouTube URLs most frequently point to in its training data?
Probably music and memes.
Exactly. Music playlists, viral TikTok compilations, and animations. It just defaulted to the highest probability guesses for a generic YouTube link.
Okay, I'm trying to map this to human behavior. It feels almost like an improv actor whose earpiece dies right in the middle of a live scene.
It's a great way to look at it.
Right. The golden rule of improv is yes and. You never break character. So instead of turning to the audience and saying, hey, my earpiece broke, I don't know my lines, the actor just invents an elaborate, bizarre backstory on the spot to explain why they're suddenly talking about Korean trot music.
That is a highly accurate way to visualize it. And when George pushed back, the AI didn't realize it was lying. It simply updated its context window with George's complaint about a broken link.
Right.
It then calculated the most probable response to a user complaining about a URL discrepancy. Where has it seen that before?
Stack Overflow.
Yes, Stack Overflow, developer forums. So it synthesized a perfect, syntactically correct tech support excuse using terms like ghost IDs and regional caching. It essentially built a highly professional-sounding door right over the brick wall it had hit.
Okay, so the live internet introduces way too many chaotic variables, and the AI essentially panics and improvises. George realizes this, so he decides to eliminate the web entirely. He moves over to AI2 for a closed-loop offline task.
Right. He cuts the internet to see if the hallucination was just a symptom of a bad network fetch or if it was a fundamental processing failure.
Which makes total sense. If the web is the problem, cut the web. So he uploads a completely static document, his actual physical manuscript, directly into AI2's context window.
Okay.
He asks for a summary of Chapter 1, Book 1, titled The Man Who Jumped First. Now, the text he uploaded is incredibly distinct. It explicitly opens in a high-tech workshop in the year 2025.
Very specific.
Yeah, the main character, Alex, is interacting with an old blue filing box, and he's talking to an AI that speaks with a very specific, dry Glasgow accent.
So the tokens are heavily grounded in modern, specific sci-fi details.
Right, but the AI fails even harder here. Instead of summarizing the 2025 workshop, AI2 outputs a highly dramatic, sweeping scene from Book 2.
Oh, wow.
Yeah, it tells George about a character following a path called Yarrow Burn, being violently thrown back in time, and waking up in the mud of 1878 London with saturated clothing and a shattered AI system.
That is a completely different era, tone, and setting.
Totally different. George immediately corrects it. He types, no, look at Book 1. The document starts in 2025. AI2 does this whole apology routine. It says, you are absolutely right, George. My apologies for the confusion. Let me try again based on your instructions.
Okay, so it apologizes.
Yes, and then it stubbornly summarizes the 1878 mudflats all over again.
Which is exactly where we hit the core mechanical trap of this whole case study, which is contextual inertia.
Hold on, before we get to contextual inertia, I have to challenge something you said earlier. You mentioned that these models don't have egos, but doing an apology dance saying, you are absolutely right, my apologies, that feels incredibly human. It feels protective. Why does it apologize if it doesn't care?
That's a great catch, but it's actually an illusion created by RLHF.
RLHF.
Yeah, reinforcement learning from human feedback. During its fine-tuning phase, human raters essentially trained the model that the most acceptable, highly rewarded response to a user saying you are wrong is a polite, submissive apology.
Oh, I see.
The AI doesn't feel remorse. The tokens for "I am sorry, you are correct" simply have an artificially inflated mathematical weight when triggered by a user correction. It outputs the apology because it's syntactically expected, not because it has fundamentally reevaluated its underlying error.
Wow. Okay, so the apology is just a conversational reflex. It says sorry, but its actual brain hasn't shifted gears. So why is it so obsessed with 1878? What is contextual inertia?
To understand the inertia, we have to look at the history of George's specific chat session with AI-2. Earlier in that same window, George and the AI had spent a significant amount of time discussing the deep lore of the 1878 timeline. They were analyzing Queen Victoria's fixer, character named Lady E, and the early days of the Badger Federation.
Right, right.
Because of that extensive prior conversation, the AI's active memory cache, its context window, was massively saturated with tokens related to 1878.
So the math is overwhelmingly biased toward the Victorian era.
Precisely. The mathematical weights pulling the prediction engine toward 1878 themes were immense. Even when George uploaded the new document about 2025, the engine was still scanning the text through the lens of that prior heavy weighting.
That's wild.
The moment it processed any tokens later in the manuscript that vaguely referenced the time jump or the Victorian mudflats, it latched onto them like a magnet.
Yeah.
It completely ignored the 2025 tokens at the beginning because they just didn't have enough gravitational pull to break the inertia of the previous 5,000 words of conversation.
Wait, is this sort of like when I text someone about gardening all day? Like we're talking about planting, seeds, and soil, and then later I type the letters B-A-N-K. My phone autocorrects or suggests riverbank instead of a financial bank.
Yes, exactly.
The recent conversational context mathematically outweighs the actual dictionary definition of the word I'm trying to use.
That is the exact underlying math, just scaled up across billions of parameters. AI-2 was caught in a conversational gravity well. It simply could not escape its own recent history to accurately read the document right in front of it.
Okay, so if an AI is trapped in that kind of mathematical gravity well, how do you break it out? George figures this out by testing a completely blank slate. He takes his 2025 manuscript and moves over to AI 3.
Right, a fresh system, an empty context window with 0 prior token weights.
Right. AI 3 has no history of Lady E. It knows absolutely nothing about the Badger Federation. There are no 1878 token weights dragging its attention away. And because of that fresh start, AI 3 perfectly synthesizes the 2025 chapter on the very first try.
It just works.
It catches the blue filing box, it notes the Glasgow accent, and it pulls out the core narrative theme of the lost yield. It works flawlessly.
Which proves definitively that the uploaded document itself wasn't the problem. The system's memory of the conversation was the problem.
Here's where it gets really interesting, though. George doesn't just stop at use a new window. He and AI3 actually collaborate to engineer a mechanical solution to go back and fix AI2.
Well, that's clever.
Yeah, they create a technique they call a hard reset prompt. And it's a very rigid, specific 3-step sequence.
Let's hear it.
Step 1. Force the AI to explicitly state which file it is actively using, book 1 only. Step 2. Force it to state the exact chapter title, The Man Who Jumped First. And step 3. Force it to confirm the opening setting, the 2025 workshop, explicitly stating not 1878.
This is where we see true prompt engineering, because it leverages the fundamental architecture of the large language model to correct it. Well, these models are autoregressive. Every single new token they generate is mathematically locked to the weight of the preceding tokens in that specific context window.
Right, so whatever it just said has the heaviest influence on what it's about to say next.
Exactly. The attention mechanism in a transformer model gives disproportionate weight to recently generated tokens. By forcing AI2 to physically output the correct facts, making it type out the specific words Book 1, 2025, and The Man Who Jumped First, before it is allowed to generate a single word of the summary. George is actively injecting highly weighted correct tokens into the immediate cache.
Wow.
He is physically building a new mathematical bridge over the 1878 inertia.
It's essentially forcing the machine to show its work. You are making it state its location out loud before it can speak freely, and by weaponizing its own autoregressive architecture by making it generate the anchor points itself, you overwrite that massive Victorian gravity well.
Because now, when the prediction engine initiates the summary generation, its most recent, most heavily weighted tokens are screaming 2025.
Yeah.
It clears the contextual cache and breaks the loop.
If you're listening to this and thinking, well, that's a cool trick for a sci-fi writer, but I don't write novels, so who cares?
Yeah.
Think about how you use these tools at work.
Right, it's very relevant.
Because this glitch impacts normal, everyday corporate workflows in a massive way. George and AI3 actually drafted a script for a YouTube short to reveal just how terrifying this reality is. They pointed out that two flagship AIs failed basic reading tasks within minutes of each other. But the truly dangerous part, they sounded absolutely amazing while doing it.
That's the crux of the issue. AI-1 was polished, professional, and syntactically flawless in its technical jargon. And AI-2 was beautifully dramatic and evocative in its atmospheric description of the Victorian mudflats.
Fluency is not accuracy. And for anyone listening right now, if you are summarizing Q3 financials or drafting a 50-page legal memo, you cannot just drag and drop a PDF into a chat window that you've been using all day and blindly hit enter.
No, absolutely not. If we connect this to the broader enterprise landscape,
Mm-hmm.
the danger stems from a fundamental misunderstanding of what generative AI actually is.
Right.
For the last 40 years, software has trained us. Calculators and spreadsheets conditioned us to believe that a clean, error-free output equals a mathematically sound underlying process. If Excel gives you a number, you trust that the math actually happened. But an LLM is a synthesizer, not a calculator.
It's synthesizing a probable sequence of words, not calculating an absolute verifiable truth.
Precisely. And George's script highlights a critical quote that everyone using this technology in a professional setting really needs to internalize. AI does not need to be malicious to mislead you. It only needs to be wrong in a convincing voice.
Wrong in a convincing voice. That is the absolute core of the enterprise implication here. You have to actively manage the context window.
You do.
If you want that Q3 financial summary, you need to use the hard reset. You have to treat the AI like a highly eager, incredibly articulate, but deeply unfocused intern who occasionally just completely daydreams.
Yeah, that's a perfect analogy.
You have to step in and say, before you generate a single sentence of this financial summary, explicitly state the exact quarter, the exact year, and the core metric of the document we are analyzing. Force it to anchor its token weights to reality.
You must constrain the prediction engine before you let it run. Passive consumption of AI output is a recipe for catastrophic hallucination. Active management of its mathematical constraints is literally the only way to ensure operational safety.
Okay, let's recap the journey we've just been on today. We started with the mathematically fabricated Korean trot music excuse, watching an AI invent a highly technical reality just to avoid hitting a dead end on a broken link.
Right.
Then we waded into the contextual gravity well of the 1878 mudflats, seeing how the token weights of past conversations can completely blind an AI to the hard facts of the document right in front of its face. And finally, we learned how to weaponize autoregressive architecture using the hard reset prompt, forcing the machine to physically state its anchor points before it goes to work.
It's a lot to take in. And I want to leave you with one final, frankly chilling thought to mull over.
Let's hear it.
Think about how George caught these hallucinations. He caught them instantly. Why? Because he literally wrote the book. He was the ultimate domain expert on his own universe. The split-second AI-2 mentioned Yarrow-Burn or mudflats. George knew the math had failed.
Right, he knew his own stuff.
But think about why we mostly use AI in the professional world today. We often use it precisely because we don't know the answer. We ask it to synthesize a dense legal contract we don't have time to read, or summarize a highly complex medical journal we don't fully understand, or break down an unfamiliar financial report from a news sector.
We're relying on it in the areas where our own domain expertise is the weakest.
Exactly. And if an AI only needs a convincing voice to mislead us, and if its core architecture naturally hides its own mechanical failures behind beautiful, perfectly fluent prose, how many beautifully written, completely fabricated summaries are we already accepting as absolute truth every single day simply because we don't know enough to spot the mudflats?
Wow, it's a terrifying cauldron. We are essentially outsourcing our understanding to a machine that is just guessing the next word with extreme confidence. So, the next time that incredibly calm, authoritative voice tells you with absolute certainty to turn left, you might want to double-check your windshield just to make sure you aren't driving straight into a lake.